So in this lesson, I'm going to look at covalent bonding and small molecules. I'm going to start with my oxygen. Now, oxygen is in group 6, so that tells me it has 6 electrons on its last outer shell. So to get a full outer shell, a stable arrangement of these electrons, it requires 2 electrons. Well, a molecule of oxygen is always diatomic. So diatomic, 2 atoms being held together. They are non-metals, therefore that tells me that they are going to be sharing their electrons. So if I have my one atom with 6 electrons and I have my other atom with 6 electrons, what they're actually going to do is they're going to share those electrons, both getting a stable arrangement of electrons, both having a full outer shell. So because they are sharing 2 pairs of electrons, we say that they are bonded by 2 covalent bonds. Now let's have a look at carbon. Carbon is in group 4, so therefore we know it's got 4 electrons on its last outer shell. So if we were to look at carbon dioxide and a molecule of that, we know it's carbon with 2 oxygens because it's carbon dioxide. So if I have my carbon atom and I bring in my 2 oxygen atoms, what I know is that they are non-metals, they are going to covalently bond together. So because they are covalently bonding, what we can see is that they are filling their outer shell, getting a stable arrangement of electrons, because now each of these has got 8 electrons by sharing those electrons, those pairs of electrons. So oxygen and carbon have got 2 pairs of electrons that are shared, and the other oxygen and carbon have 2 pairs of electrons which are shared. So therefore we have got 4 covalent bonds. So it's important to note that carbon requires 4 covalent bonds because carbon is in group 4. Oxygen was in group 6, therefore it required 2 covalent bonds. So when we understand that, we can start to look at these small molecules and see how many bonds that they have with which of the atoms. So I've got carbon dioxide, I've got oxygen, I've got water here. So each time we know that they are covalently bonded because they are sharing electrons, we also know how many covalent bonds based on which group they're in. Hydrogen is in group 1, so it needs 1 covalent bond. Oxygen is in group 6, so it needs 2 covalent bonds. So we can see that carbon dioxide is CO2. We can see that water is H2O because we need 2 hydrogens with 1 oxygen, and oxygen on its own is O2. Now, what happens if we bring extra small molecules in? So let's say we have a second carbon dioxide molecule. Well, what you have to understand is that there are weak intermolecular forces between molecules. And because there are weak intermolecular forces between the molecules, a molecule of oxygen, a molecule of carbon dioxide, a molecule of water has strong covalent bonds within the molecule, but between the molecules are weak intermolecular forces. Now that's important because that explains why these small molecules have low melting and boiling points. They have low melting and boiling points because it doesn't require a lot of energy to change its state. And therefore, what that also means is that our small molecules tend to be found in the gaseous state or the liquid state because there is not a lot of energy needed for these molecules to be in that state, to break those weak intermolecular forces.